learners! This video lesson is the second video that deals on solid geometry. It will continue to demonstrate how to determine the volume of prisms. Likewise, it will showcase strategies on comparing the prism's volume and areas of the cross-section after slicing through the solid. Strategies in analyzing and solving problems related to the topic are showcased to let you gain an understanding on how these are done so that you will be able to successfully answer geometry problems similar to these in the future. If your lesson is on solid geometry, particularly on prisms, or if you have an assignment on this topic, or if you are preparing for a test in math or a test in geometry in particular, or you're someone who's interested in learning math, then this video is for you. This video lesson is a continuation of the first video on solid geometry entitled Solid Geometry, Prisms, Volume, and Cross-Section. The first video explores on some of the basic concepts in solid geometry, particularly volume and cross-sections. These two concepts will be used extensively on this video lesson. Thus, it is recommended that you watch the first video before watching this one. The link is down below. Now recall that prisms are three-dimensional figures with two parallel faces that are identical, called the bases, and flat lateral faces, which are rectangles. As in the previous video lesson, we will only consider right rectangular prism and right triangular prism on this video lesson. These are the prisms that are upright when sitting on their bases like this. As you see, a prism is not all the time sitting on its base. A prism has length, width, and height, hence its volume is determined by these variables. The discussion on how the formula for the volume came about is on the previous video. In mathematical form, the volume of all prisms is B times H, where B is the area of the base of the prism and H is the height of the prism. If the prism is a rectangular prism, B is the area of the rectangular base, which is length times the width. If the prism is a triangular prism, B is the area of the triangular base. Recall that the area of a triangle is 1/2 the area of a rectangle. Thus, if the area of the rectangle is length times the width, then the area of the triangular base is 1/2 the length times the width. Because a prism is three-dimensional, that is, it has length, width, and height, its unit of measure is in cubic units of length, like cubic feet, cubic meters, cubic inches, etc. Now, when a prism is sliced, its cross-section is produced. A cross-section is a 2D surface obtained upon slicing or cutting through a 3D figure or solid. When a right rectangular prism is sliced perpendicular to its base and parallel its lateral sides like this, it exposes a cross-section congruent to that lateral side. Now, when a right rectangular prism is sliced parallel to its base like this, it exposes a cross-section congruent to the base. As what you have observed, the cross-section obtained depends on the orientation of the cutting or slicing made. Okay, so let us look at the sample problems that follow and find out how to answer them. Here's the first problem. Clark is planning to use a piece of wood shown below for his artwork. What he needs is just a part of the wood that is cut diagonally through the whole length as shown. What is the volume of the piece that he will use for his project? The dimensions of the wood are shown. Option A, 9.0 cubic feet. Option B, 6.0 cubic feet. Option C, 4.5 cubic feet. Option D, 3.0 cubic feet. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? You're correct. We're asked to find the volume of the part of the piece of wood that Clark will use for his artwork. What are given? We're given a figure of the wood with dimensions. The problem also states that Clark will only use a part of the wood, that portion that is produced after cutting the whole wood diagonally through its length. Okay, look at the figure, learners. The figure tells us that the piece of wood is a right rectangular prism. Do you agree? Now, the problem states that Clark will only use a part of the wood that is cut diagonally through the whole length. Let us cut the wood then and see what will come out. Let's go. Okay, so here are the cut pieces. Clark will only use one of these two pieces that are produced. Now, what type of prism do you think does this cut resemble? You're correct, a right triangular prism. Now, the problem requires us to solve for the volume of this prism. Let us then have again the formula in solving for the volume of a prism. So the volume is B times H, where B stands for the area of the base of the prism and H for the height. Look at the base of the piece of wood that Clark will use. What shape is the base? You're correct. The base has the shape of a triangle. Thus, its area is 1/2 the length times the width. So the volume of the triangular prism is 1/2 times length times width times the height. Were you able to follow, learners? Okay, let us look at the figure of the original piece of wood and the piece that Clark will use. The original figure has dimensions, right? Can we now label the dimensions of the piece of wood that Clark will use for his project? You're correct, we can. Let's go and label it. Putting the dimensions will help us with the substitution process with ease. Okay, so plugging in the values into the equation gives us, multiplying 2 feet and 1.5 feet gives us 3.0 square feet. Multiplying 3.0 square feet and 3.0 feet gives us 9.0 cubic feet. Dividing 9.0 cubic feet by 2 gives us 4.5 cubic feet. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option C. That was easy, right? Let us continue by doing sample problem 2. Here's the problem. Consider the 3 identical right rectangular prisms with square bases shown. Each prism is sliced as follows, producing 2 smaller prisms. Case 1, sliced diagonally and perpendicular to the base. Case 2, sliced parallel to the base and midway between the 2 bases. Case 3, sliced perpendicular to the base and midway between opposite lateral surfaces. One of the 2 smaller prisms produced in each case are shown below. Part 1. Which statement is true about the volume of the smaller prism shown? So option A, the volume of the prism produced in case 1 is larger than the one produced in case 2. Option B, the volume of the prism produced in case 2 is larger than the one produced in case 3. Option C, the volume of the prism produced in case 3 is larger than the one produced in case 1. Option D, the volume of the prism produced in case 1, case 2, and case 3 are the same. Now part 2, which statement is true about the areas of the cross-section produced due to slicing? Option A, the area of the cross-section produced in case 1 is larger than the area of the cross-section produced in case 2. Option B, the area of the cross-section produced in case 2 is larger than the area of the cross-section produced in case 3. Option C, the area of the cross-section produced in case 3 is larger than the area of the cross-section produced in case 1. And option D, the areas of the cross-sections produced in case 1, case 2, and case 3 are the same. So as usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What is asked in the problem, learners? Okay, so here we are to determine two things. First, we are to choose which statement is true about the volume of the small prisms produced in each case. Second, we are to choose which statement is true about the surface areas of the cross-sections produced in each case. What are given? We are given 3 identical right rectangular prisms with square bases. Information on how to slice or cut the 3 prisms to produce 2 smaller prisms are also given. Okay, so we will slice this prism according to the instructions given in each case so that we will have an idea how the smaller prisms are produced. Then, we will use the resulting prisms to answer the questions. Let's go. For case 1, we will slice the prism diagonally and perpendicular to the base. Learners, this is the diagonal of the base on top. We will slice the prism through the diagonal going downward, perpendicular to the base at the bottom. Here we go. Here are the resulting small prisms, learners. For case 2, we slice it parallel to its base and midway between the 2 bases. Okay, let's go. Here are now the 2 prisms produced. For case 3, we slice it perpendicular to its base and midway between the 2 opposite lateral surfaces. Okay, let's go. These are now the 2 prisms produced. Getting 1 small prism from each case, we now have here the set. With the results that we have here, which statement is true about the volume of the smaller prisms shown? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Remember this, learners, the original prisms were identical in the first place. Now, slicing each prism according to the instructions in each case is actually dividing each prism into halves. The outcome in this case may not be the same shape as what we have here, but the amount of space occupied by each smaller prism is 1/2 the space occupied by each original prism. Since the original prisms are identical or were identical, that is, they have the same volume, dividing each one into halves will produce smaller pieces with volume 1/2 the original piece. Thus, a smaller piece will have the same volume. There you are, learners. I hope you were able to follow. We will now move on to the second part. The second part deals with the areas of the cross-sections. Look at the cross-sections produced in each case, learners. What do you notice about the cross-sections? You're right, each cross-section resembles a rectangle. Recall that the formula in getting the area of the rectangle is length times the width. So that it will be easy for us to compare the areas of the cross-section in each case, we will label the length and the width of each cross-section. Let's go. Can we now compare the cross-section of each, learners? Okay, let us analyze the situation further. Look at the diagram carefully. Again, to solve for the area, we need the length and the width. The length in case 1 and case 3 are the same, while the length in case 2 is the shortest. Do you agree? Let us look at the width this time. Which has the longest? Let's check. So, it is in case 1 where the width is the longest. This is not surprising, for this is the diagonal of the base of the prism. The width in case 2 and case 3 are just the sides of the original square. Do you agree? With that, which statement is true about the areas of the cross-sections obtained due to slicing? Is it option A, option B, option C, or option D? Okay, so the answer is option A. There you are, learners. I hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, solid geometry is the study of three-dimensional shapes or figures. Second, a geometric solid is a portion of space which is enclosed from the rest of the space by two-dimensional surfaces. Third, a prism is a three-dimensional figure with two parallel faces that are identical, called the bases, and flat lateral faces, which are rectangles. Fourth, right rectangular prisms and right triangular prisms are prisms that are upright when sitting on their bases. Fifth, the formula for the volume of a prism is B times H, where B is the area of the base of the prism and H is the height of the prism. Sixth, the unit of measure for solids is in cubic unit of length, like cubic feet, cubic meters, cubic inches, etc. Seventh, the cross-section of a solid is a 2D surface obtained upon slicing or cutting through a 3D figure. The shape of the cross-section depends on the orientation of the cutting or slicing made. Eighth, when solving a problem, you must read it and may read it several times when needed to know what you are looking for, to determine what are given, and to figure out how the given information helps find what you are looking for. Ninth, when a figure is given, make use of it and modify when needed. It is there to help you analyze and solve the problem. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.